This is section 2.2, where we will learn about histograms, which are graphs of frequency distributions, but with quantitative variables, right? As opposed to bar graphs, which were qualitative. Right, so let's take an example. We have this BMW model data with suggested listing prices. I went ahead and made a frequency table, which you would need to make a histogram by hand, but if you just use Minitab, you can just enter the data, and then you don't have to do this. But one thing I do want to point out about this frequency distribution, right, because this is the main difference between histograms and bar charts, is that you don't have categories in the x-axis. You have classes, right? There are ranges of numerical values, right, because this is quantitative data. Okay? So note that a frequency table for quantitative variables is the same as one for qualitative variables, except with classes instead of categories. A histogram is a graph used to illustrate a, well, possibly relative, frequency distribution. Right? It's like a bar graph, but the x-axis, again, is quantitative, and the bars are touching. Right? The, I guess I should say the lower class limit and upper class limit are the, well, lowest and highest values of a data class, right? And the class width is, well, maybe what you might expect. Upper class limit minus lower class limit. And just want to point out that all classes have the same class width, okay? All bars are the same thickness, just like, in a bar graph, right? Usually, there's no hard and fast rule, but usually we want between 5 and 20 classes in a histogram, unless this data set is really, 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 really large, right? So how would we create a histogram? Well, you choose a lower class limit for the lowest class, then you choose an upper class limit for the, well, again, lowest class, and so then you compute the class width for all classes, and then you use a relative frequency or a frequency distribution to draw the graph. Or use Minitab, right? And so what I've done is I've entered the data into Minitab for the cost of all of the cars. Okay, so we just go to graph, histogram, simple. Select that variable, and voila, we have our graph. Okay, and so we'll just kind of go ahead and copy and delete that, stick it right in here. And there you go. Okay. Now, histograms for discrete data are analogous, except the data class may be a single value. right? So we have another data set here, for example, 2. I've again gone ahead and entered all the data into Minitab, right? You can pause the video and do this if you want. It may take a little while, but feel free. But anyway, to create a histogram, we again just do this and this. This time, make sure to choose days, right? And that is our histogram, right? Right, and so this is the answer to question 1, a histogram, right? For number 2, right, think about how frequency and relative frequency are related. Think about how the graph might look different or not, right? Maybe I'll say for both of these, right? And lastly, think about how we would describe the shape of this histogram. Certainly seems a little, I don't know, little all over the place. There's sort of a pattern, but then it really drops off. So for this one, I will also, I'll say, well, a couple of things. It rises, then drops multiple times. I'll just say, especially at the end. Okay. So, speaking of shapes, what are the different shapes that we've drawn? Well, one thing that you may have heard if you've taken a stats class before, but skew or skewed means tail. I'll just say tailed. So a graph is skewed to the left, for example, if it has a tail to the left. Similarly, a graph is skewed to the right if it has a tail to the right. So a skewed left graph would look something like this. Maybe something like this. And then eventually it's got like big values, right? Something like that, maybe. Try that one a little bit better. Maybe something like that, right? Where the rough shape is like it's got a little bit of a tail going on, right? And then, of course, the analogous thing would be, right, the opposite. We've got big values here, and then all of a sudden, something that drops off like that, right? Right. So this is skewed left. This is skewed right. Okay. A graph is, well, we use the term symmetric or bell-shaped. We'll later call it normal. If it's shaped to left and right of the center is the same. So an approximately bell-shaped graph would be something like, I don't know, something like this. And it could be steeper or less steep. I don't know, maybe something like that, where you see it's roughly symmetric, right? Okay. A graph is bimodal. If it rises, falls, and then rises again. bimodal graph, for example, a graph that looks like this. Right? That's bimodal because it dips down and then goes back up. Right? And lastly, a graph is uniform if all bars have exactly the same value. That's pretty boring. You don't see this too often. Not the most exciting thing to examine because, you know, it's just everything's the same. But it happens sometime. And the shape is just... Okay. Alright, and we also can draw, what are these called? Line graphs called frequency polygons. By really what we do is we just construct a histogram. I guess actually, yeah, they could be frequency or relative frequencies. We construct a histogram. You find the midpoint of each class, and then graphing a, I'll just say a point or a dot for each midpoint with a line in between. So like, I don't know, just an example. Let's maybe do the car data. It's just a slightly nicer looking graph. Let's copy that. X that out. Let's see if I can paste it over here. Whoop, no, didn't let me do that. It's still on this one. Okay, whatever. But what we could do for this is we could be like, okay, here, here. See, I'm just finding the midpoint of each of these things, and then I'm just going to connect them. Maybe I'll use black. Maybe use thinner a little bit just to keep the points. Right. And pretend these lines are perfectly straight. Right, there you go. Now, if you just, you know, erase, I guess I can actually do that, right? I could just erase that, right? And if I, you know, put the axes back and everything, that would be your frequency polygon, right? Right, and I guess we do have something called an ogive, right? I had actually never heard of this. I guess a frequency, so we call it a frequency ogive. I had never heard of this before using this textbook. But it plots cumulative relative frequencies. This is not really something we worry about too much, so I'm just going to let you try that one. That's what we've got.